Thanks everyone for going before me. Yeah, my name's Raphael Hagen. Today, my lightning talk is just kind of like a quick overview of some of the open source tools we've been using in a project and like why you should check them out. I should have added X-published tiles because we've been playing around with that too. So, but luckily Deepak covered that. So a little bit of background. I work at Carbon which is a small nonprofit that works to improve the transparency and scientific integrity of climate solutions through open data and tools. A lot of the work we do at Carbon is involves like gridded climate models and climate data, sort of in this like czar X-ray ecosystem. And a lot of it we put on the web through Carbon maps. So there's like a direct route rendering of czar chunks in the web. On the left, you can see like a project of the Atlantic Ocean. You can see chunks being visualized. And a lot of this data is usually like, model scale, so maybe 25 or maybe even 4 kilometer scale. But we're working on a new project and we're using an input data set that was 30-meter scale, so just way larger. And this 30-meter raster data set covers CONUS. So we wanted to look at some new tools and say, how could they help us with this processing? As many of you guys know in this community, working on big distributed computations with ZAR and X-ray can be tricky, especially with Dask. It's a lot of ways to shoot yourself in the foot. Um, and in this project, we weren't really sure about how complicated the science part of the processing pipeline would get. Like it might start simple, but then it might get really complex. And we didn't want to just like blow up the Dask task scheduler and have to rerun CONUS a bunch of times and have things fail. So we went with a different approach that's been done for a while, where instead of trying to process all of it at once, you split up the data into individual regions and you write the whole shape of it into like an empty skeleton or template. This has been possible with like standard ZAR for a while and X-ray. The one downside is you don't really have much of a state. So if you're writing a bunch of chunks and one of them fails for some reason, you don't really know that that chunk is missing unless you do checks. So you're really kind of in this like weird land where you're not sure if you've like finished the job. Luckily, there's a really cool new tool from Earthmover called Icechunk. This gives you transactional rights for ZAR. It's kind of like a Git history for ZAR. Um, and the really neat thing about this is that we could write chunks and then commit each chunk with a certain region ID so that if we're running a bunch of chunks and some fail, if we rerun, we can just do the chunks that haven't been done. So those missing chunks could be reprocessed. So this is really nice. So you can just get the state, you can like checkpoint and go forward as you're processing. The other neat thing about this and Icechunk is you can write uncooperative distributed writes. So each of these little regions is a job, and we could grab something like lithops or coiled batch and say, hey, go process this work, write it. And if that job fails for some reason, then you can go and just write that chunk again. Another part of this project was taking this high-res 30-meter product and saying, can we sample this to building polygons? And luckily, there's this really cool data set from Overture that provides building polygon outlines for the world, but for our use case, the continental US. And that's about 175 million polygons. And sampling that to a 30-meter raster is just a GIS desktop nightmare. If you tried this in ArcMap, I think you would like, pull your hair out and then quit your job. Luckily, there's some really cool new tools in the sort of GIS Python land. One is duckdb spatial, which provides all of these crazy geospatial operations in a really nice SQL syntax. And then if you pair that with geoparquet, which is a really great modern vector format, you get incredible performance that just seems like it's magic. So we could pair this with that 30-meter raster and then sample all the buildings in the US. Um, as you can see, we're zooming from the continental US all the way down to my hometown in Missoula to get like the building individual scale. This is done by making these multi-scale pyramids that we had two folks talk about. But this is with Tippecanoe, so making vector tile approximations. But at Carbon Plan, we like to do a lot of ZAR and raster in the browser. We have a small utility called ND Pyramid, which kind of like can generate these multi-scale ZAR pyramids. But it's pretty limited in performance, and it definitely breaks down from going to like trying to make a 30-meter pyramid at like 12 or 13 zoom levels. So we had to look at a few more options to improve it. So Max Jones at DevSeed put out this really cool report of like the state of the art of like, or state of the union of like resampling methods in Python last year. And it seems like the Open Data Cube resampling methods were like the best in resource usage and performance. So we paired their methods with all the really good performance improvements in ZARV3 and the Obstore backend. And it gets really, really high concurrency for all these tiny little slippy map pile chunks we have to write for our pyramid. And that allowed us to build these 30-meter raster pyramids. So I have a kind of low quality GIF, but we're zoomed all the way out, and we're going to zoom in all the way down like 12 or 13 levels down to the individual pixels. Um, and yeah, so this was mostly thanks to all these new developments and all these new tools. So yeah, just want to thank all the people working on these projects. It's really cool. There's been so much development and progress in this community. And you should go check out all these plus X published titles.